Thank you for joining us today for the Listeria Control Toolbox, Laboratory Methods, Software, and Educational Resources updates. My name is Sarah Waters, Educational Coordinator for Certified Group, and I'll be your host for today's session. We're excited to have you with us as we focus on practical tools and resources to help reduce the risk and prevalence of Listeria in food production environments. This webinar is designed for food industry professionals who are committed to strengthening food safety programs through improved testing, data management, and education. A quick housekeeping note, this session is being recorded and we'll have time for questions at the end. Please use the Q&A feature to submit your questions at any time. It's my pleasure to introduce today's presenter, Dr. Alex Brandt. Dr. Brandt is the Chief Science Officer for Microbiology at Certified Group and has been with the organization for over 12 years. In this role, he leads microbiology technology services and contract research operations. He works closely with laboratories and customers on method validation, troubleshooting microbiological results, and providing on-site support, especially for sanitation and Listeria-related challenges. He also oversees multiple contract research sites that conduct shelf life studies, challenge studies, and process validation work. Dr. Brandt is actively involved in industry organizations and technical panels and is well known for his passion for helping customers solve complex microbiological issues. We're very fortunate to have him with us today. Dr. Brandt, thank you for joining us, and I'll turn it over to you.
All right, thanks, Sarah. Well, good morning, good afternoon, everyone. Good day, I guess. Thanks for joining us today again on this webinar for one of the topics I'm really passionate about, which is Listeria, specifically Listeria control. We, I think, have had a lot of attention on Listeria again as of late, and I'll kind of talk a little bit more about that here in the next few slides. But we hear a lot about Listeria control from the plant side, and what do we need to do for sanitation, and what do we need to do for raw material controls and other GMPs and things of that nature. But we don't always hear about what we have on the laboratory side to help out with things. And so that's what this webinar is designed to do today, is to really talk a little bit more about some of the testing tools that we have in the toolbox, and some software tools as well that laboratories are able to provide to kind of help you with your Listeria control measures. And so we'll go into that, and we'll also talk a little bit about some educational resources that are just newly available that we were helping out with. And so we want to kind of highlight those at the end of the presentation. So we'll do that, and we'll also take some questions here at the end. So let's go ahead and jump off into it. So as I mentioned, kind of the overview for today is really just kind of talking about the resurgence of attention for Listeria, looking at some of the biology of Listeria, looking at some of the routine testing tools that we use, some of our strain typing tools that we use, some of our environmental monitoring software, and some of those new educational resources that we have available, as I mentioned. All right, so why this resurgence of attention for Listeria? Really, it kind of comes down to a lot of these recent outbreaks that we've had associated with Listeria monocytogenes. So it started in 2024. We had a very large outbreak involving meat that was sliced at deli, so ready-to-eat meats. Pretty prominent producer of that product that was implicated into that. There was a total of 10 deaths from that among the 61 cases that happened with that particular outbreak. So this kind of, caused a lot of people to kind of take notice again that Listeria may not be as controlled as we think it is, especially in RTE meat establishments. Then we had another outbreak in 2025 that came very soon thereafter, with 14 deaths out of the 42 cases involved with that one. This was involving supplement shakes that were going to different institutions and food service. And then we had another outbreak here just this past summer involving ready-to-eat pasta meals, where we had 7 deaths out of the 28 cases there. So as you see here, a lot of different types of products that were implicated here. We've got, all of these from multi-state outbreaks, a lot of hospitalizations, and, several deaths that were involved with this, unfortunately. And so, obviously there became a lot more attention on Listeria and looking at what are we doing as far as controls for Listeria. we've had a lot of good guidelines in place for many years, but there was, I guess, a question now again of are we actually doing as much as we could be doing? And so both USDA and FDA took note of that. USDA in particular came out with another couple of new measures that they put in place. These are some notices that came out in December of 2024. One of those is where they're actually taking more questionnaire information from food production facilities now that produce ready-to-eat post-lethality exposed products. They're collecting information. There's like a 16 question um, questionnaire that gets filled out every week with a lot of different things about practices in the facility and results. So they're actually taking this data and really monitoring it more so now for Listeria control and looking at, Listeria risk of different establishments as a result of that. So, USDA took some measures with that. They also decided to um, take the procedures that they use in their microbiology laboratory guidebook and expand those to also test for non-Listeria monocytogenes Listeria species. So this includes all the other species that are part of the Listeria genus. And so this kind of is casting a wider net. Rather than just looking for Listeria monocytogenes, they're able to look at this data now and evaluate a plant based on whether it's seeing some other indications that there might be a Listeria problem due to the harborage of Listeria species other than monocytogenes. So a lot of action there on the USDA front as a result of some of these things that have gone on with these outbreaks. So before we dive into some of the other things here, I just want to kind of take a minute to just refresh everybody on Listeria monocytogenes biology. So as I mentioned on the previous slide, there's other Listeria species. So monocytogenes is one of 27 species in the Listeria genus. That list kind of continues to grow. But it is the only true human pathogen that is part of that genus. We refer to it as LM a lot of the time, so you'll see me refer to that here in the slides going forward. But there are also two other groups of species that are part of the genus, Listeria sensu stricto species, which are those that are closely related to LM. So think of Listeria inocua, Listeria walshemeri, Listeria ivanovii, a lot of these that are actually pretty common in a lot of the places that we find Listeria monocytogenes. Then we also have the Listeria sensu lato species, which are some of these newly discovered divergent species that kind of are out there on the fringes. They don't quite behave the same way as Listeria monocytogenes, and not all the test kits actually detect all of these. And maybe they don't actually need to because they're not as closely related to Listeria monocytogenes, whereas, the test kits that we have available should all be finding all these Listeria sensu stricto strains along with Listeria monocytogenes. So a little bit more about that too. Listeria is a gram-positive bacterium, so it's very environmentally hardy, and it's psychotrophic, so it can grow under refrigeration. It's also moderately salt and pH tolerant. So it's a pretty hardy bug when you think about things. So it does have a very good propensity to grow in a food processing plant environment. It's also an intracellular pathogen where it causes systemic illness. So it really has two life cycles, an environmental life cycle and an intracellular or host life cycle that it can turn on and create a foodborne illness. So the combination of all these factors together make it a really high risk for post-lethality exposed ready-to-eat refrigerated foods because they are processed in environments where Listeria can grow. Listeria can then grow to high levels on that product, and then they're typically eaten without being exposed to some sort of heating step or some step that would kill Listeria again. So they are very high risk for these types of issues with Listeria monocytogenes. With regard to the illness of Listeria monocytogenes, again, very high risk for immunocompromised people, the elderly, infants, pregnant women, and HIV patients. Complications for this are very serious: meningitis, septicemia, stillbirths, and spontaneous abortions. Nearly all cases are foodborne. And if we look at the most recent numbers that we have from 2019, I know it's about 7 years old, but that's the most recent numbers we have. There's about 1,250 illnesses per year in the United States, with 1,070 hospitalizations and 172 deaths. So pretty significant foodborne illness burden there. we start looking at food attribution, there's a lot of different products that actually are attributed to Listeria monocytogenes illnesses. Some of the higher ones here are dairy foods and vegetable row crops and fruits. But this is data coming from about 2022. So I would say that since then we've had several other outbreaks, that are associated with, again, ready-to-eat meats and things of that nature. So I would imagine some of these meat items that are kind of a little bit on the lower scale over here would probably be a little bit more on the left-hand side here, closer to where they actually have a higher attribution. So, but again, the point here is that there's a variety of different foods that can harbor Listeria monocytogenes. It's not just ready-to-eat meats and dairy foods anymore, as we kind of used to think about. It's also cut, vegetables and other things as well. So when we're getting into the testing toolbox, one of the key things that we have to look at here are the tools that support environmental monitoring programs. And so environmental monitoring programs, or EMPs, are critical prerequisite programs where we collect samples from environmental sites and test those to assess control of LM. Again, LM survives and grows very well in niches and food processing plant sites, and particularly those that harbor nutrients and moisture and allow for biofilm production, where they can actually evade some of the sanitizer action from sanitation procedures. And so what happens is you have raw materials and other inputs that bring LM into a food production process. And then if you have a site like this where it can actually grow, it can actually proliferate in the production plant environment, becomes a key source of the hazards for finished product safety. And most people, when they're actually testing as part of their EMP, are looking for Listeria species, and they simply react to Listeria species positives, but they don't go really into further, deeper analysis. And today we're going to talk a little bit more about what you can do about going beyond just getting a positive or negative result. I know that was one of the questions from one of the registrants at the very beginning is what can you do to go beyond that? And that is something we're going to talk about. There's a variety of different methods that you can do for screening tests, but again, these other tools can help you go to the next level with actually differentiating what's going on. There's also finished product testing that gets done to support Listeria control programs, but this tends to be a lot less frequent than the testing that's done to support EMPs. It's really meant to be a final verification for the entire food safety system, including the EMP. And some people will test Listeria species on these products, but it's much more common to test Listeria monocytogenes on finished product. And so, again, a lot of people put a lot of focus on the EMP and a lot less focus on the finished product unless it's like required for a customer. But there are people that still do this, and so it's very important to include that in the toolbox here as well, and think about what's going on with that. But it can add some complexity to your testing program. I will warn you about that. And we'll kind of talk about that here on the next slide. So when we're talking about routine testing, there's a lot of different methods out there, right? And, you can kind of take your pick at what you want as far as the test kit platform. There's a lot of different things that can go into that. I can talk all day about selecting methods, and we can have that in another discussion if you'd like. But it really does come down to, familiarity with the assay, familiarity with the testing lab running it, how familiar are they with running the assay, turnaround time, costs, all these different things, right? But, I will say that, that you have a lot of options, which is the good thing there, because most every major testing platform has validated test kits for environmental samples for Listeria species or Listeria monocytogenes to support EMP. So, I got those check marks there by a sponge and a Q-tip swab. You can pretty much be sure that any test kit that's out there that's worth its salt that is going to be offering a Listeria species or a Listeria monocytogenes kit is going to have validations for those types of samples. However, when we start getting into product samples, that's where things get a little bit dicey. So, not all product samples are validated for each major testing platform. So if you were to look at the toolbox, we'd say we're missing some tools in those cases. Most of your traditional matrices, like hot dogs, deli meats, cheeses, and other dairy items, have validations. And most matrices are validated at a 25-gram sample size. But what about when we get into these non-traditional items like produce or bakery items or low moisture foods? I know we had several questions from the registrants about low moisture foods. What about those? What about meal kits? That was one that caused a recent foodborne illness outbreak. I would say that we don't necessarily have validated methods to cover all of those things. And especially if we start getting into larger sample sizes, like 125 grams or 375 grams, it's very likely that we don't have some sort of a validation for that. So, with broadening categories of food being implicated for Listeria contamination, we need to consider what's in our toolbox and whether we need to consider expanding the method validation matrices and sample sizes to cover that, because we got to have tools if we want to be able to do something. So, as I mentioned, most of these test kit platforms do to get a tool for testing is to go through an AOAC accreditation process and show that a method is validated for a certain matrix at a certain sample size. And as at a lab, we will often recommend for our customers to follow these methods that are validated through AOAC. But or even internal validations that a test kit manufacturer has done in AOAC style are also acceptable. But again, what happens if there's no validated method that exists? What if we don't have a tool? Well, we can always go back to the cultural methods like FDA BAM or USDA MLG, but those take too long. And a lot of people are like, hey, we don't have time for that. So what we can do is we can actually conduct a method validation and extend that method to another matrix and another sample size. So we can either have the kit manufacturer do it, or even as a lab, we can do it as well, and actually show that it works and it's validated for that particular matrix. Or if we don't have the capabilities or the resources to do a full validation study, we can at least do a fit for purpose study to show that the test kit will work as intended for the matrix. So you need to really do this so that you make sure that the new matrix and any sort of sample size modifications don't create false negatives. That's really what we do not want. We do not want to have false negatives because we didn't validate our tool. So again, if we don't have the right tool, we can create one. It just takes some time, and we actually do need to make sure that we go through the process of creating that tool for the purpose that we need it for. So beyond just regular positive negative testing, I want to get into strain typing. So this is where we actually can determine the microorganism similarity beyond the species level. So it's not just saying, hey, I've got Listeria monocytogenes strain A. I actually have Listeria monocytogenes strain A, strain B, and strain C now. I have actually different things that I can see. So if you look at this little graphic here to the right, these are all X's that are in the exact same spots. If we look at just positives without strain typing, they just look like a bunch of X's all over the place. Now, if we start looking at them and we look at strain types, now we can start seeing something a little bit more detailed here. We can actually see where particular strains are moving around a facility and where they're concentrated at. So this helps you link these positive results together and helps you get to the root cause of contamination issues. And this will help you with some of your decision making if you have multiple issues going on at the same time. It also helps you understand if you have a persistent or resident strain, or if you're constantly getting transient organisms that are being introduced into the facility all the time. So what a lot of people think that we have to do for strain typing is next-gen sequencing or whole genome sequencing. Now, that is the preferred method for government-run laboratories because it replaced PFGE and it's considered the gold standard. The cost is down, the speed is up, but it's still very expensive and time consuming to complete. But a lot of people don't want to really do this because there's a lot of data that the government has generated as a result of this. And a lot of it gets housed in the Genome Tracker network that's housed within NCBI. So a lot of companies are very hesitant to use whole genome sequencing to do their strain typing, and rightfully so. But what I'm here to tell you is that that's not the only option that you have. You actually do have other options. We actually use a couple of different options within the certified group network, including the Hygiena RiboPrinter and the Bruker IR Biotyper. And so I'm going to go into a little bit more detail on what each of these technologies is and what it does. So first of all, the RiboPrinter. So the RiboPrinter is an automated system. It actually takes the DNA of an organism and uses a frequent cutting restriction enzyme to cut it up into lots of small fragments. And so then we blot those with probes that are specific for the ribosomal rRNA genes. So if you see down here in the bottom right corner, there's several different rRNA genes that are involved in production of rRNA. And so these genes are pretty highly conserved, and you can actually have some variability around them, though. And so when the enzyme cuts, it actually cuts in a specific pattern, and then we can actually do a blot for those particular genes, and they show up as a pattern. So we basically get like a fingerprint, which you see right there underneath underneath the machine right there. We can load up to 8 samples at a time in the unit, and the results are actually generated within about 8 hours. So it's actually a pretty fast mechanism for getting strain typing done. As I mentioned, all the different consumables go into it. There's a lot of different cassettes and pieces that kind of come together here, and the machine does it all pretty much automated all by itself. You just got to load everything, and then it goes through the whole process. But basically what it's doing behind the scenes is you're taking your sample, you're preparing that, lysing it open. You're basically fragmenting the DNA into lots of tiny pieces, as you see right there. It's basically an enzyme chopping it up into lots of tiny pieces. And then we separate those out with a gel, and then we transfer those to a membrane. And once it gets transferred to the membrane, we can actually dot blot it, basically, like we're doing there, and look for those specific genes, the rRNA genes with probes that are fluorescent, and then we do a detection on it. And so when we do that detection on it, we can actually see those probe patterns from where the DNA separated out and made those fingerprints. The data then gets processed, and then it actually groups strains together based on the likeliness of their patterns. So if you look at it down here below, we can see some new samples that we added to a particular library here. Well, those then actually matched another pattern we already had in the library from a previous set. And now you can see that they're all basically grouped together. So it actually uses some logic to be able to know where those banding patterns are at and then do that grouping. And then we get a nice printed report here at the end. So, but what does this tell us? Well, it tells us, again, whether or not we've got the same strain that we're seeing over time, or we've got different strains, or it can even with a massive contamination event you have all at one time, it may just tell you if you had multiple strains involved in that as well. So we actually use that a little bit more on the non-RTE side. Sometimes we're dealing with E. coli and E. coli contamination and massive contamination events. We can use the riboprinter and the IR biotyper to look at a massive contamination event and whether all the strains that contributed to that were related. So this is a pretty neat way of doing things. It does not necessarily have to generate the species information. You can actually keep it in its own library away from everything else. And so if you have your own library of strains that you've had this done on, you can actually have it to where you don't know what species this actually is. And so that will help kind of keep that blinded if you don't want to know if it's Listeria monocytogenes or if you just want to know if it's, just a generic Listeria. So then we get into the IR biotyper for strain typing. And this one actually is, again, a different type of strain typing that doesn't use whole genome sequencing, and it actually doesn't use DNA at all. It actually uses cell surface molecules and uses FTIR technology to generate spectra that can be compared to one another. And so it's not a genetic typing system or an identification system. It's really just kind of a glorified FTIR instrument, which we use for even like when we were doing foreign material identifications, we use FTIR to compare two different materials in terms of their chemistry. Well, we can also do the same with different microbial isolates and strains and do comparisons. So really the first step here is to obtain a pure culture of an organism. Just get that on a plate and then you create a lawn. The only limitation is that you have to be able to make a homogeneous suspension. So you have to be able to take this bacterial organism and grow it on some sort of non-selective media like tryptic soy agar, blood agar, or something like that. Or you can even do, MRS, like for lactic acid bacteria, which you need to validate that that works. You can also do this for yeast, so off of PDA and things of that nature. But If we start getting into things like molds, it doesn't work very well because it's difficult to make a homogeneous suspension for a mold. But like yeast and lactic acid bacteria, Listeria, Salmonella, E. coli, all these different things, we can actually make a pretty homogeneous suspension. And then once we have a pure culture, we make a lawn plate, and then we go through all the different steps here. So we take a loop full of that culture off the lawn plate. As you see right there, there's a pretty good glob on that blue loop right there. We'll then place that into a tube with some water and alcohol and some little metal beads, and that shakes it up and it makes a nice homogeneous suspension that we then spot onto this carbon steel plate right here, basically, where you've got these different spots on there. And so we tend to run everything in triplicate. So we'll take that particular isolate and run it in 3 wells and let that plate dry out. And then once the plate is dry, we set up the software in the Bruker IR biotyper to know where each of those wells is at for a particular isolate, where each of those replicate wells is at. And then you just load it into the machine. The machine does the rest. It does a scan on every single one of those wells, and it provides a result back in the form of a spectrum. And so what it does for you is it takes all these spectra and it does some math on them, and then it looks at the similarities. And so you actually get a hierarchical cluster analysis, data analysis, and then it takes those results and displays those as either a dendrogram, as you see over here on the left. In that dendrogram, we can see clusters of isolates. So based on the distance between these clusters and those like points out there on the left where you see where there's joining lines together, that's the similarity of different groups of isolates. And so, if we have a pretty strong cluster there, then those are isolates of the same strain. As we start, moving into other clusters and looking at, how they're joined further out there, then that's actually things that are not related or even less related. If that is kind of hard to view, sometimes that is kind of a little bit harder for folks to view. You can also look at it as a scatter plot in a basically principal component analysis, and you can see clusters of isolates there. And these tend to follow very closely with what we see on the dendrogram side of things as well. And so it can help you look at those in a little bit different way. But overall, this helps you see clusters of isolates and determine relatedness. And then this will help you see if you've got harborage or repeated contamination over time. Either way, and there's other different strain typing tools out there too. There's some that are available from Rheonics. There's some that are available from Hygiena with fast sequencing. There's a lot of different things. So we just highlighted a couple right here. But what you need to know is that if you take strain typing and do some of your work on that, you can actually see pattern information that links your positives together, and then you can start going back to your map that you've got of your facility and start overlaying some of the positives with these strain types. And that helps you see better spatial and temporal relationships between those positives. That then helps you direct some of your corrective actions, if you have to make some sanitary design modifications, and then even, help sanitation know what they need to do to eliminate the source of the issues. So, and then if it returns in the future, you already have a head start on the troubleshooting because you already know if you've seen that strain or not and what has been a problem in the past. So the next thing I want to kind of talk about are software solutions. So, I'm going to talk pretty heavily about our software solution that we offer through Certified Group called Emma. But this is true for a lot of different programs that are available for EMP management. And so really what this does is kind of help you take that EMP management to the next level. So rather than taking a bunch of color-coded stick pins and putting them on a map of your facility on a dartboard or on a cork board, you can actually do a little bit more sophisticated work with a software program. Again, not that any of that stuff is wrong, and sometimes it's actually better to do that in some cases when you have to make a really quick look at things. But I just wanted everybody to know that there are a lot of software programs out there to help you with your Listeria control management and actually, automate some of the things like sample collection and sample collection tasks and labeling and things like that, which can help you focus a little bit more on your actual, digestion of those results and like looking for troubleshooting rather than just being focused on all the administrative tasks that you have to do day in, day out. So, Again, our program that we have within FSNS and Certified Group is called EMMA, which stands for Environmental Monitoring and Mapping Application, but there are other programs out there like EnviroMap and Neogen Analytics that do a lot of the same things. So just a little overview of our system with Emma. You've got a dashboard that you can look at all of your different tasks and results and things that are in motion. And then we have underneath that maps. So you've got mapping capabilities where you actually add your sites. And then from there, you take those sites and things that you put into your maps and you create plans and swab site scheduling. And then from there, you can actually do task management and submissions. You can also do remediation in cars and do some customized data reporting as well. All these things we'll kind of get into here shortly. So on the dashboard of the software, you can kind of see all your different request statuses that are going on. You can see your test results. It allows you to see, either at the plant or organizational level based on your responsibilities and roles within the organization. You can also filter and look at different tasks and be able to work out task management and the tasks that you have yourself to complete. So this is really nice because again, this kind of gives you a one-stop shop for like looking at everything you've got going on from Listeria environmental monitoring samples, and you can actually track things as they're coming in, what's open, what's closed, and what needs some of your attention. Again, just trying to make this a lot easier for everybody so that way you're able to focus more on fixing problems in your plant and less on all these administrative tasks. So the first layer within the software is basically the map layer. And so this is the very base layer. This is what starts it all. So you can upload a map of your facility with as little or as much detail as you want. And then you can actually start creating sample points based on that. Right now, everything's still in 2 dimensions. I know we had somebody ask about 3 dimensions, and I think we'll get to that question later. Not something we have the capability for yet, but definitely something that we want to look to in the future because it's not always just looking at it this direction, but it's also looking at it from top to bottom as well. But right now, with the 2 dimensional aspect of it, you can add sample points, give those descriptions, and give them names. And then you can give them different zone designations. Most of us operate on the zone designation of 1 through 4, so you can add that. You can also say if it's a mobile site, if it's going to move around, you can also assign risk. You can give it a whole lot of other attributes then that you can also look at and use to classify it as you want. So once we get all of our sites set, then you actually start creating different scheduled plans or discretionary plans based on how you want those sites to be sampled. And so if you're looking at a discretionary plan, you select and schedule these individual sample sites based on your needs. If you're looking at a scheduled plan, it just basically creates tasks and swab sites seamlessly with all these chosen. It randomly creates this for you, so you don't have to actually go in there and do it. It just kind of automatically comes up in your tasks. You can also do a risk-based plan. So this is something that you want to maybe focus on high-risk sites or medium-risk sites or low-risk sites. You can actually include that, and then it creates a plan based on those. And you can also create an ad hoc plan. So like if you decided that, hey, I need to go sample something because you saw something, then you can create an ad hoc plan. So good example would be, well, hey, we had a leaking roof this morning because we had, 5 inches of rain last night and something burst through on the roof. And now we've got all the standing water everywhere out here on the production floor. Well, they did clean up a lot of it. But you really want to go know what your risk was because of that. So you maybe want to go out there and sample those areas. So you'll create an ad hoc plan and go do it. So this helps out with managing all those different things and then getting the tasks into Emma. Once we actually have that done, then the plans will, like I said, automatically generate tasks, and then you can assign those to individuals to complete. So if you've got other people within the system here, you can say, hey, look, I want you to go take these swabs and then, actually get those ready to go to the lab. And so if you've got 3 or 4 different technicians, you can say, hey, technician A, technician B, technician C, each of y'all is going to take these different ones, and you can assign those out into the software. Then once they come back with those completed tasks, they can submit those as samples. And so when they do that, you go through a sample submission form that's in the software, and it'll actually create a label for you, and then you can send that to the LIMS system that we use to generate LIMS sample IDs. And so then once those come to the laboratory, they're ready in our system for LIMS. And so then it already pops up, and all they have to do is receive those and start the testing. And then what's really nice is once all the testing is done, all the results go back into the LIMS system automatically. So no more sitting there and hand keying things into an Excel spreadsheet from COAs. It actually all is electronically data transferred and goes right back into your map, where you can actually see all your results. And so one of the other things that we have here is your remediation and corrective action reporting. So this actually allows you to put all of your documentation in one easy place for easy retrieval. So if you had some positives or a failed site, you can add all your appropriate remediation information there. And then you can actually look even at some of the different vector sites and things like that. If you come out and take vector swabs of those sites after they're positive, you can then actually add those to this as well. So this is really nice. So if you have, investigations going on from a regulatory person or an auditor, they ask for some of this information. You can pull it up right here, and everything is all in one place. You don't have to be hunting through a bunch of binders to look for follow-up results in any of your corrective action paperwork. It's all nice and neatly organized. This is really kind of nice that for a lot of people that want to use this for corrective actions. And then there's the customized data reporting. So again, the customized data reporting here is what the nice feature of Emma has in terms of what you can do. So you can actually create just some customized reports that have different categories and different risk information, zones, sample types. You can filter all that data and create a nice little report that pulls out in Excel. Or you can actually look at it in the mapping feature as well. So as I mentioned, all that goes back into the mapping feature, and you can actually look at all those results in a geospatial format where you can start seeing trends over time. You can see, positives over time. We even have a playback mode where you can hit start and it'll actually do a time lapse progression of different sites. So again, helps you with looking at, hey, where are things coming from? Where do I need to go with those and actually start focusing my efforts. We also have a feature called the profile that's on there too, and that's where that strain typing information can come in. So we know that people have different strain typing tools. As I mentioned, there was a couple here that we utilize, but there are also other different tools. And so we kind of made it very open-ended to where you can create whatever profile you want to call it for a particular strain type, and then you can overlay that data in there as well. And that provides another layer of discrimination between these different positives in the site. So just want to make sure everybody's aware that these software capabilities are available to you, and you can actually use that for helping manage some of your Listeria programs and really kind of help you with that control aspect. The last piece I want to talk about here are some education updates. And so, one of the things that we stay very involved with here from FSNS and Certified Group is the Meat Institute and the Meat Foundation. And, we've done a lot of work with them over the years. And we were invited to help them out with some education updates over the past year. And so, want to highlight some of that because, for some of the folks that are on the call here today, some of this stuff is, pretty much old hat. You're like, I've heard about strain typing, Alex. I've heard about software, nothing new. But some people have never even heard about that. So that's why we want to kind of talk about it a little bit today and why we wanted to highlight that. And for some people, there may be even a more fundamental understanding of things that's needed just about Listeria control and intervention. And so we want to really kind of highlight some of these modules that are now available for free for people to go out and actually get a little bit more of a basic understanding of Listeria. So we can talk about lab tools and stuff like that all day long, but some people really want to know, some of the meat of the matter with regard to how do we do control in the plant. And so this is a really good place for you to go. And so um, for many years, the Meat Institute really just held this advanced Listeria monocytogenes intervention and control workshop, and did that as an in-person workshop. That has excellent content, but with the resurgence of all these Listeria issues, they said, hey, let's take a step back and like actually make some more fundamental information, foundational material for plant personnel to use in an online format. And so, as I mentioned, a bunch of us industry experts came together and created a lot of new course content that they made into some training courses with a company that specializes in adult learning. And so then we've got now the Foundations of Listeria Control that was born in Q4 of 2025. And so in that, I guess, coursework, there are a bunch of different modules. So, very basic stuff. What is Listeria monocytogenes? An introduction to Listeria control. And then we look at different key strategies for controlling Listeria monocytogenes. Prevention, how do we keep it out of the facility? Sanitary equipment and facility design, how do we make sure that if it does get in there, it doesn't stay in there? Processes for the product. What are we doing on our products to make sure that, there's no raw material transient strains that are coming in that are getting through? Like, are we making sure we've got good validated cooking procedures and things of that nature? Sanitation, making sure that we do control it and get it out of there if it is in there and it does create harborage. Looking at environmental monitoring, we talked a little bit about that here today, but it goes into a little bit more depth on that. How do you investigate positives? Again, strain typing can help out with some of that. We do highlight that there as well. Then looking at things like process disruptions, like maintenance and weather events and, different things that happen like, fires or leaks or things of that nature. What do you do when you get into those kind of situations, and how do you manage process disruption with those? So a lot of good content here that I want to make sure everybody's available or aware of that is available. And so, how do you get to this? You can go to the Meat Institute Foundations of Listeria website. This link will take you right there. And you can sign up totally for free. I did a little sign up yesterday too, just to make sure everything's working correctly, and it's still working good for me. And so what you then do is you get into that online course content, and you start just going through there on demand. It's all self-paced and mobile friendly as well. And you actually get some certificates or certificates of completion after you're done with that. So there's a certification aspect to it as well. We've also started doing this at the IPP annual meeting as well. So this past year at the IPP annual meeting in Atlanta, there was an in-person option to be able to come to this where we actually did about a full day of different topics with regard to the foundations of Listeria control, and even had some hands-on activity. So, for another, I guess, level of that, I would encourage folks to look at that, going forward in the future. So that kind of looks, I think, like we're at the end here, 12:45. I think we've got some time for questions. So that concludes most of what I was going to talk about. So I think we'll go ahead and switch it on over to questions and see if anybody's got anything that they have that's a burning topic. So Sarah, do we have any questions?
Yes, we did get one while you were talking about the testing for strain testing. Can you confirm we can test a sample and determine if multiple samples are different strains, but without confirming that specific strain or species?
Yes, you can. So that is one of the things that the Bruker is very good at. The Bruker IR biotyper will allow you to do anything and compare similarity, and you do not have to know the species. The RiboPrinter does it similarly, but you have to be very careful. Like, you actually have to segment it out and make sure it's in its own library so it doesn't try to assign it, because it can try to assign patterns from time to time. We can do it. You just have to be very careful with it. But for the Bruker IR biotyper, the way it's set up with projects and things of that nature, there's really no way for you to infer the species unless you put it into a database where you do have known species, and then it makes a match to that known species, and then you would be like, okay, well, still it's not a confirmatory identification, but hey, I've got two Listeria or I have this new strain of Listeria that I put side by side in here, and there was Listeria monocytogenes I knew about. It would be inferred that those are the same strain, but again, it doesn't give an exact identification. But that's a very good question.
Thank you. And then we've got another one. Should Listeria be monitored routinely in low moisture, less than zero point 0.2 AW RTE production areas that have no expected moisture introduction?
Excellent question. So this is one that's been up for debate for a while now. Traditionally we've thought about, you know, only high moisture foods, with high water activity being the ones that are problematic for Listeria. And so, yes, they continue to be the primary ones that are problematic for Listeria because they allow for growth most of the time. If it's a high water activity food and there's no antimicrobial inhibitors to inhibit the growth of Listeria. So, and under refrigeration, it'll still grow. So think of things like cheese or, deli meats and things of that nature. There's going to be some outgrowth if you don't have antimicrobials and things like that in there to control it. Now, for low moisture foods, we wouldn't expect any growth, right? So, we wouldn't expect, if you put something in like a dry powder or chocolate or something like that, you put Listeria in that it would actually grow because there's not enough water activity there to allow for growth. But the problem is that you can get survival. And so survival is not the same as growth, right? Survival is it's still there, it's still alive, it just isn't growing. So we've always been really kind of hyper focused on things that allow for growth, but things that allow for survival can also be a problem because they can still serve as a vehicle for Listeria to be ingested, right? And even more so can become a problem if we take them and use them and put them in a condition where Listeria could be present in those products and then be given all the conditions that it needs to grow. So think of like, some sort of a powder that gets rehydrated or a frozen food that gets thawed out and held at room temperature for a long period of time. All these are different things that, can actually contribute to some Listeria growth. So I guess a long answer to a short question, but it is still important, I think, for us to be mindful that we should be looking for stuff in a low moisture environment from time to time. I don't know that it's necessarily as high risk as, a high moisture food. And we really haven't had any major outbreaks, thankfully, related to low moisture foods and Listeria, but we have had several recalls. There have been several recalls that have happened within the past, 5 or 6 years with things like nuts and tahini and peanut butter that were all related to Listeria contamination. And so I think we have to be mindful of that, even though those products don't support growth, that you can have some survival in there. And it is a good, prudent practice to, have some sort of environmental monitoring program that at least addresses that on a occasional basis, at least.
Okay, thank you. And then we have another one. What is the limitations and concerns with USDA or FDA to do in-house pathogen screens?
Good question. I don't know that there's any limitations to doing that. I know there's probably some concerns with doing that, obviously, from a control standpoint. Having live controls inside of a food production plant environment is not always the best idea. That's why a lot of folks do use third-party labs for that particular aspect of it. They want to make sure that, if we're going to be using a positive control, that it's not something that can quote unquote get out into their plant. There are some strains out there that, are obviously other Listeria, like Listeria inocula and things like that, that you could use as a positive control that's not a pathogen. But at the same time, if you're just doing routine monitoring for Listeria species and that gets out into your production plant environment, it can be a little bit of a problem. So I know there's not necessarily a restriction on doing that if you can manage it, but I know there's definitely some concern with doing that, just given all the propensity for that to be able to, possibly be tracked out into the production plant environment being very close by.
Okay, thank you. And then another one that kind of goes along with that, short from having live organisms in my facility, how do I conduct a positive control from my sampling team?
Yeah, that's a good question. So, really, the best way to do it is to either use some other type of organism that's kind of an indicator that you can use. And if you're looking at like swabbing capabilities and, recovery, um, you can do something with a generic like APC or something like that. If you're really wanting to look at, proficiency of testing for Listeria, again, that's going to be really hard unless you're doing some sort of like a heat killed strain and taking that and using it in your process. That would be the only way I could say it would potentially work. But yeah, it can get really difficult with trying to get live organisms into a production plant to do a lot of these things.
Thank you. And then we have another one. Any emerging methods to cut down on presumptive positive, but do not confirm out Listeria hits in finished products on the various testing platforms?
Another good question. I wouldn't say there's been a lot of updates to the methods here as of recent that would really, I would say, help us out in that regard in reducing, presumptives. There are always going to be some presumptives that do not confirm out, right? There's always some level of those. We're never going to get 100%. If you show me any method that is exactly 100% all the time, it it would be great if that happens, but I can tell you there's no perfect method out there. But we have, can do things to improve the methods. And so one of the things that, has really been done a lot here recently is to look at DNA cleanup procedures. So if there is for some reason some overrun of residual DNA from dead cells, we've been looking at using DNA cleanup procedures to get rid of DNA that's not in a live cell, and we've been looking at that from a Listeria standpoint. It really kind of was more so for salmonella, and especially for things like, pet food with salmonella, where you've got, really high levels of salmonella potentially in the raw material, and then subject it to a lethality process and leave behind a whole lot of DNA that could potentially trigger a positive. Well, the same thought kind of goes along with that for Listeria in some cases. So, like for instance, we had a really hot harborage site in a plant. Maybe we hit it pretty hard with some sanitizers and chemicals, or we did a chlorine dioxide treatment or something like that. Fumigation, and then we came back and we sampled it. Maybe it's all dead, but the DNA was still there. So in those kind of cases, we can actually potentially include the DNA cleanup step in front of those samples to be sure that we don't really have any interference from dead cell DNA. So again, that's probably one of the biggest refinements we've done in some of the methods here recently. Other than, just looking at validating more matrices. A lot of these methods have been around for a while and they're pretty tried and true. They just have some little minor modifications that we can make to help get them to a higher confirmation rate.
Okay, thank you. And then we've got one more. Where are the best places to randomly check in a pack house environment in a greenhouse, which contains no kill steps, such as drains, food contact surfaces?
Okay. Well, again, anywhere that you've got accumulation of residue and moisture, so those are going to be your hot spots. So, I mean, if you're looking at, I guess a packing house or greenhouse, things where you've got soil accumulation, a lot of places where you've got water drippage, things that soak up a lot of water. I always look at stress mats or foam things that actually are around. Those all can soak up water and nutrients, and those create like a nice little environment for Listeria to grow. In my opinion, things like stress mats and stuff like that, the best place for them is in the dumpster. But some people have to have them, obviously for ergonomics. But you just need to keep them clean and well looked at. Again, drains, cracks in the floor, those are all different spots. I would look inside of equipment, hard to clean spots, rollers, niches, in between conveyor belts, frayed conveyor belts if you're using, still a belt type conveyor with not interlocking chains. All those different places. I mean, there's 100 different places you could probably look, but you just look for places that accumulate a lot of moisture and water that are protected from sanitation.
Thank you. And then we have how can 2D mapping and 3D mapping of positives, presumptives, and negatives aid in investigation and sanitation environments?
Another good question.
Improvements, sorry.
Yeah, no, another good question there. I kind of hinted at it a little bit earlier too, that, once you get into that three-dimensional mapping, in addition to 2D mapping, it really helps. 2D mapping is still good because you can kind of see where everything is at, like we talked about in the Emma program. But when you start getting to 3 dimensions, then it helps even more because now you're seeing, well, is something coming from overhead? Is something above something else that is dripping down? I have a really good example of one in my head that I noted from, late last year, where we had Listeria up on the higher level of this one plant in the mezzanine area. It was dripping down through an exhaust vent for a chill screw, and it was dripping down into that area. And so, where did it come from? It was coming from up above, and so we didn't really catch it with any of the like surface level monitoring that was going on, except for seeing it hit here and there. But once we started going upwards and started looking up in a three-dimensional fashion, we were able to find things. So if you were able to see that in a 3D fashion, you could start looking at some of those data points and say, hey, something up here is actually causing the problem that's happening down here on the floor level. And you could actually, get to a root cause much faster.
And then we have one more. If final product is low moisture RTE, but there is a wet processing side, how important is it to monitor the wet processing areas aggressively for Listeria? Should EMP and product testing be focused on the RTE risk assessment only?
That's a tough one. But I would say, yeah, you are going to expect to find Listeria on your raw material side a lot of times. And you really should have a really big focus on your RTE side because that is where, if you have contamination, post lethality, you're going to have issues. Um, but I still do say that you probably still need to monitor your raw side just to understand what you've got coming in. Yeah, some people are like, well, that's not good information, and my regulatory people will start getting on my case about it. Could be that that's the case, but I think if you make an important distinction with them and say, hey, look, this is my raw side. I know there's going to be some stuff there, but I really want to know what might be there. So that way I have a better idea and know that if my process is managing it, I think they'll give you a little bit of leeway on that. But I feel like it's still good to do that just so you know what you've got in your process. And if you know that your process can manage it, because if you've got really high loads coming in, you better be sure that you're really adhering to whatever processing steps you've got in place to make sure you get good lethality and it's not coming over to the other side.
Oh, thank you. Thank you everyone for joining us today and for your thoughtful questions. A special thank you to Dr. Brand for sharing his expertise and practical insights on strengthening Listeria control programs and using today's tools and technologies to support food safety efforts. We hope you found this discussion valuable and that you're leaving with ideas that you can apply in your own facility.